The next AI chip war may not be won by the processor. It may be won by the memory stacked beside it. An accelerator can perform enormous amounts of math and still sit idle if model weights and intermediate results cannot arrive fast enough. Micron says one HBM4 stack can deliver more than 8 terabytes per second. That is the number to watch. Not only compute, but how quickly data reaches compute. HBM is not an ordinary memory module plugged into a board. Multiple DRAM dies are thinned, stacked, connected vertically, tested, and placed close to the accelerator on an advanced package. HBM4 doubles the interface width to 2,048 pins. That proximity saves energy and raises bandwidth, but it also joins several difficult manufacturing steps. The commercial product is no longer a single chip. It is a qualified package whose parts must work together. Micron reports more than 11 gigabits per second per pin and greater than 8 terabytes per second per HBM4 stack. The company says that is more than twice the bandwidth of its comparable HBM3E stack, with better power efficiency. These are manufacturer specifications, not a guarantee for every workload. But they show why memory is strategic. Longer context, multimodal inference, and larger models all increase the volume of data moving around the accelerator. Supply depends on two clocks. Memory makers need enough advanced DRAM wafers and acceptable stacking yield. Packaging providers need interposers, substrates, bonding tools, and test capacity. TSMC says its larger 5 reticle CoWoS S-class packaging entered qualification in 2025, with volume production planned for 2026. A delay on either clock can delay the final accelerator, even when the GPU die itself is ready. The value pool spreads across memory wafers, stacking, test, packaging equipment, substrates, and the final system. Scarcity can support pricing, but higher selling prices do not flow equally to every supplier. A company with strong yield and qualified capacity may capture more value than a supplier adding unproven capacity. The key accounting questions are utilization, depreciation, customer concentration, and how quickly new factories produce saleable units rather than engineering samples. HBM is increasingly co-designed and reserved earlier than commodity memory. Customers care about a specific accelerator platform, capacity, power envelope, and delivery schedule. That can produce longer commitments and deposits, shifting some demand risk toward buyers. It does not eliminate risk. A platform can slip, yields can disappoint, or a customer can redesign. Read the contract boundary. Forecast, allocation, purchase commitment, and recognized revenue are 4 different things. New capacity sounds fungible, but qualified HBM is not a barrel of oil. Stack height, base die, interface, thermals, and packaging flow must match the target platform. A supplier can own wafers without owning the final delivery date. That is why the supply map must include memory makers and advanced packaging providers together. The bottleneck can migrate from wafer starts to bonding, test, substrates, or qualification, as each link expands at a different speed. Potential beneficiaries include memory producers, packaging houses, test equipment vendors, bonding tool makers, and materials suppliers. The reversal is equally important. Aggressive capital spending can create excess conventional DRAM supply if AI demand slows or HBM consumes fewer wafers than expected. Strong HBM pricing can therefore coexist with weakness elsewhere in memory. A durable thesis follows product mix, yield, capacity timing, and customer commitments instead of assuming every memory dollar is the same. Ask 5 questions. Is the number per stack, per accelerator, or per rack? Is the speed a specification or measured application performance? Does capacity refer to wafers, stacked memory, or packaged systems? When does volume production begin, and has the customer qualified it? Finally, who carries cancellation and inventory risk? If a claim cannot answer those questions, it may describe impressive technology without describing a deliverable product. The AI race is no longer a contest of processors in isolation. It is a contest to move data through a physical stack at acceptable power, yield, cost, and volume. HBM4 makes that stack faster, but it also makes packaging and qualification more important. Follow the entire machine, DRAM wafer vertical connection, base die, package, accelerator, and contract. The next shortage may appear beside the GPU, before it appears inside the GPU.